So next, if we designing seat pan depth, for seat pan depth, corresponding anthropometric variable is buttock popliteal length. Now which percentile data should we use? For this purpose, we may use 5th percentile, 50th percentile and 90th percentile. So let us see what happens. Say first, assuming that we are using fifth percentile. So while you are using 5th percentile, then 5th percentile person is sitting comfortably, but for 50th percentile, what is happening? Their thigh is going out. For 90th percentile, they are also not getting sufficient thigh support. Next, if we use 50th percentile data for this purpose, then what will happen? So this is a side view of the seat. If we design as per the 50th percentile, then it is exactly matching with the buttock popliteal length of the 50th percentile. This is the buttock popliteal length of 50th percentile. It is exactly matching. But what will happen in case of 5th percentile? 5th percentile will sit like this. They cannot use the backrest because they cannot move. This is the 5th percentile. If we design as per the 50th percentile, then what is happening? 50th percentile, it is exactly matching with their buttock popliteal length and this seat depth. But for 5th percentile, they cannot use a backrest because their popliteal area is getting stuck here. They cannot go backside. For 90th percentile, what is happening? 90th, they are with bigger or larger body dimension. For them, what is happening? They are not getting proper thigh support because their buttock popliteal length is more. So in this case, 50th percentile, if we decide this seat pan depth as per the buttock popliteal length of 50th percentile, then 50th percentile is comfortable, but for 90th percentile, they are not getting sufficient thigh support. On the other hand, 5th percentile, they cannot use the backrest. Now, third scenario, if we use 95th percentile. So this is the side view of the seat. This is the seat. If we design this seat as per the popliteal height, buttock popliteal length, this is the buttock popliteal length of 95th percentile. So 95th percentile can sit, they can use backrest also because it is exactly matching with their buttock popliteal length. So 90th percentile they can sit comfortably, but 50th percentile they cannot use the backrest, and 5th percentile they are again sitting forward. So they are also not able to use the backrest because they cannot go backside. The popliteal area is getting stuck here. Now the question, then which percentile buttock popliteal length should we use for deciding the seat pan depth? If we have only these three options, 5th, 50th and 95th, then we should go for 5th percentile. Why 5th percentile, not 50th or 95th percentile? In this case we mentioned if we use 50th percentile, good number of people will be accommodated. But in this case we are not going for 50th percentile, we are going for 5th percentile. Because if we use 5th percentile buttock popliteal length, then what will happen? Everybody will get buttock support, but probably they will not get thigh support, because thigh support is not important in this case as their feet is on the ground. They are keeping their leg either in extended or vertically on the ground. So as the leg is supported on the ground and they are getting buttock support, so thigh support is not that much important. So if we use 5th percentile, then what is happening? This will be the scenario. 5th percentile, it is exactly matching for their buttock popliteal length, 50th percentile, there is no sufficient thigh support, but they can sit like this, and 95th percentile, they can sit like this, because thigh support is not important, as they can rest their leg on the ground. But if we use 50th percentile data, in this case, what will happen? 50th percentile data, if we use 50th percentile data, then only 50th percentile is comfortable. If we use this 50th percentile data for this seat span depth, then 50th percentile person, he can sit comfortably. But what about 5th percentile? They have to sit like this way. This popliteal area is getting stuck with the forward portion of the bench, forward portion of the chair. So for that purpose, they will not be able to use the backrest. For this reason, we are using 5th percentile. But generally, 5th percentile, in this case, 5th percentile is too less. So that size is too small. So we can increase it. Instead of 5th percentile, we can go up to 20th percentile or 30th percentile. But as we have at the very beginning, we mentioned only we have to select from this 3 percentile value, then we have to select 5th percentile instead of 50th percentile. But we can increase it little bit more, because 5th percentile value is too less. So we can go for 10th percentile or 20th percentile up to 30th percentile as per our requirement. So what we understand from this one, from this chair dimension, although this is a single product, a single facility, for various design dimension, we need to consider various anthropometric variable, and that anthropometric variable also is of different percentile value. Sometimes for this purpose we are using 50th percentile popliteal height. For this one we are using 95th percentile hip breadth. For this dimension we are using 5th percentile. It may be 20th percentile or 30th percentile also, whatever, but in this case we are assuming 5th percentile. So in this case we are using 5th percentile buttock popliteal length. So for a single product, its various design dimension, we are using corresponding various anthropometric variable and their different percentile value. So for a single facility design, it never like that. For this chair design, we will only use 5th percentile anthropometric data or 50th percentile anthropometric data for all design dimension. It's not like that. For different design dimension, we have to consider corresponding anthropometric variable, and for that corresponding anthropometric variable also we have to identify which should be the appropriate percentile value. Now, while designers or engineers are designing some product or facility, then they have to follow various strategies of using percentile anthropometric data. One of those strategies is design for average individual, second design for extreme individual, and third design for specific range of individual. Others are design for physically challenged person, design for specific individual. So we will discuss one by one. First one is design for average individual. While you are designing any product or facility for average individual, as we have already discussed about the height of the chair or height of the seat span height of the bench or seat span height of the chair, in that case we are using 50th percentile data. If we use 50th percentile data from normal distribution of anthropometric data, we have already understood that if we use 50th percentile data, which is the average or mean value, then good number of people whose body dimensional value is nearby that 50th percentile, they will be accommodated. So in many situations we use 50th percentile anthropometric value for designing various types of facility. So one example is sitting bench design for students, as we discussed. Next one, design for extreme individual. Extreme individual means people with shorter body dimension or smaller body dimension or larger body dimension. Here two things are there. One is maximum dimension, another is minimum dimension. So this is very important to note. Maximum dimension. For extreme population, if we want to accommodate wide range of people, then in one case we are using maximum dimension. Now with example it will be easy to understand. Say we want to design door height. If we want to design a door, so this is the door. For that purpose, what should be the height of the door? Height of the corresponding anthropometric variable, obviously human head height or stature. For stature, we will use which percentile value? So first we want to discuss about this one. Minimum height of the door. What should be the minimum height of the door? Minimum height of the door should be the maximum height of the population. Mean we will use 95th percentile data for this purpose. So minimum height of the door is the maximum height of the people. So in this case we will use 95th percentile data of stature, head height or stature value. Now, so this is important because while we are talking minimum height of the door, but we are considering maximum height of the pupil, that is the 95th percentile. Even we can use 99th percentile, or we can even allow more than that also, so that everybody can go through the door. While we are using 95th percentile stature value, then 95% of the population whose head height value is less than 95%, whose head height value is less than that, they can easily pass through the door. On the other hand, if we want to position a door latch for locking the door, in case of door latch, what should be the maximum height? Maximum height from the ground for the door latch. The maximum height from the ground maximum height of the door latch from the ground is the minimum height of hand reach value. So if we want to design this one, for that purpose what we need to consider, so this is the person, so hand reach value, vertical hand reach value, and also we need to consider in that case 5th percentile hand reach value. If we want to position a door latch, what should be the maximum height? It should not go more than that. If it goes more than that, then people with lower percentile hand reach value, they will not be able to use. For this purpose, we need to use 5th percentile hand reach value, so that students or that particular population for whom we are designing, they can use that facility. if we decide the position of this door latch as per the 5th percentile hand reach value, then what will happen? All other people whose hand reach value, vertical hand reach value is more than 5th percentile value for that population, everybody will be able to use. So 95%, if we use 5th percentile vertical arm reach value for positioning the door latch, then all other people whose hand reach value, vertical hand reach value is more than 5th percentile, that 95% of the people will be able to use that. Only people whose hand reach value is less than 5th percentile, they will not be able to use that one. Next, so it is important, minimum dimension, minimum height. So minimum height of the door, while you are talking about minimum dimension, then we need to consider the maximum percentile of the population for that particular arithmetic variable. While you are talking about the maximum height of the door latch, or maximum height or maximum dimension, while you are talking about maximum, then we need to consider the minimum percentile, 5th percentile or 1st percentile. Next point is design for specific range of individual. In many situations, as we described about the adjustable chairs, so chair height or this height of this tabletop, if it is adjustable, if we can adjust the elbow rest height, this is my elbow rest height, if we adjust this height of the table surface from 5th percentile elbow rest height to 95th percentile elbow rest height, then starting from 5th percentile to 95th percentile elbow rest height, all these people will be able to use this table. Similarly, in this example, automobile car seat, automobile seat is being used from 5th percentile to 95th percentile. Wide range of people will use that facility. So for that purpose, we start from 5th percentile to 95th percentile. The seats 5th percentile as well as 95th percentile, all the people should use the steering wheel. Their feet will be on the accelerator, and clutch or brake, meaning different types of pedals. So their leg position is fixed, hand position is on the steering wheel. Now they have to move the seat forward and backward as per the requirement. So in that seat travel limit, we have to set that seat travel limit in such a way so that 5th starting from 5th percentile to 95th percentile, people with body dimension, particularly in this case say leg dimension, starting from 5th percentile to 95th percentile, everybody should be able to use that one. So if we want to accommodate a wide range of people, then we need to consider this type of adjustable feature. Designer for physically challenged. If we want to design for physically challenged, their body dimension is also different from normal population. So for that purpose, different database we need to develop, and those data after percentile calculation we need to use. Similarly, design for specific individual. If we want to design any product or facility for a specific individual, say for example director's chair. So director's chair will be used by directors only. So for that purpose we need not to go for percentile calculation or percentile anthropometric data. In that case, we can directly measure the body dimension of that particular individual, and accordingly we can make his required furniture or any other product or facility, because in that case that facility will be used by that particular individual. So individual specific product we can also develop. For that purpose, percentile data is not required.